Yo, what's up, everybody? Welcome back. Today we are once again working on our attempt to make it so that I can see in video games. So this is a screenshot from Arc Raiders, a game I've been playing a lot of, way too much of. And in this game, it's really dark. And you might say, turn on your flashlight, because there's like flashlight in the game. And you can do that, right? The problem is that this like very dark thing is like actually not that dark if you change your monitor settings, right? So I go into my monitor and I change the gamma curve, and all of a sudden, like, I can see what's in there. And I think that that's like frustrating because you are playing against people who are doing this, right? And so what I do now is I go into my monitor every time I play the game and I change my gamma. And that's kind of frustrating, right? So what would be nicer is if I could do it in software, at least, and attach it so that I can make a random daemon that says like, hey, when I launch Arc Raiders, apply this gamma curve. And then we could also do like some extra stuff like digital vibrance, brightness, contrast, all the things that like you have on like the NVIDIA settings panel on Windows. I play on Linux, right? And specifically, I play on Linux in Wayland, which makes this problem like much more complicated. To the point where it like is I don't think it's really solved. I didn't really check if Windows Proton games are running in X-Wayland, but from the gist I got from reading the docs, I don't think that an efficient GPU curve adjustment in Wayland is simple to implement. We did a lot of digging here. We got into like the Kwin source code, the window manager that I'm running here, and the best thing that we have in terms of a balance between efficiency and getting what I want is there's this thing called color correction, right? So I buy a monitor from a store. They have a bunch of LEDs that they've stuck, or like I guess they have what, like an LCD back panel plus a bunch of like little filters or whatever. Anyways, they have a monitor they've manufactured that is supposed to show a certain thing when you say red 5, right? I say, give me 5 red, somewhere between 1 and 255 reds. Show me what that looks like. And the monitor won't be perfect. It's supposed to look kind of like this, right? It's kind of like this. And you might say, why not, shouldn't, like, so for each red value here, like each value on the x-axis, output, like, we'll call this like number of red photons emitted, maybe. Emitted, hand wavy, like some sort of like metric of the physical energy output by the system. And you would say, shouldn't it be like this, like linear, right? For just I put in 5 and you give me 5 times the brightness as if I put in 1. And this is kind of like a combination of a historical thing where CRT monitors were originally just happened to output this power curve, and so we used it. And then also a kind of like functional thing where all of our images started like being encoded backwards from this to like offset this change. And it turns out that this is kind of like a desirable feature because the bit depth ends up being like higher at lower brightnesses, which we notice a lot. Like, I don't know if you guys have seen when you like watch a like H.264 encoded movies and they show like a black section of the screen and you just see like these patchy blocks everywhere because like you're really sensitive to changes in dark where you're not as sensitive to the same changes in light, right? Anyways, all that to say, my monitor's curve might not be perfectly like this, right? And so what I can do is I can like buy a piece of hardware that's basically like a camera and software that go together. You staple the camera to your monitor and say, hey, run through a bunch of colors and like check what it looks like. And after that, it spits out this thing called a color correction profile, which you assign in your system settings here. You go, hey, let me use a color profile here, and it will like make all of the colors look right. Now, this mechanism that Kwin uses to apply this, because remember, this is on Wayland, you don't have like Wayland applies this. You have my specific Wayland implementation, in this case, Kwin applies this. And what they do is they assign a transform matrix and a color curve lookup kind of to the GPU. And the GPU will like adjust all of the colors to match basically the colors that they need to output the red that they wanted, right? So if they're like, hey, I'm a little too dark in all these sections, it will like find, if he's like, I wanted it to be here and you put here, he'll like find the part on the curve that matches that and he'll put that instead. Hand wavy. And what we can do is we can abuse this to trick Kwin into making all of our stuff brighter, right? So if we want to apply, you know, if this is like the linear curve, if we kind of want to make like everything like a little bit brighter in the darks, like this, to kind of like bend this part out a little bit, we can lie and say, hey, our monitor actually was darker in all of these places than expected. Could you please adjust all of the outputs to make them look right? And what we're actually doing there is forcing it to go brighter in some areas. We also have control over this like 3x3 matrix that allows us to apply colors, or transform colors between different spaces, and we can kind of use that matrix to increase digital vibrance, increase contrast, increase brightness. We can kind of do all of these things by saying we are fixing the way that the colors look on our monitors. And so today's task is to kind of make a GUI to output these things. We've in the past week or so experimented with generating these profiles, and we have like a pretty good understanding of what each of the fields are. We still haven't generated a profile that's like perfect, but I kind of know what the next steps are there, so I'm not really too worried about it. And so what I want to do is I want to generate a UI where we say, hey, load a few pictures, let me adjust the gamma, or brightness, contrast, digital vibrance, whatever on this thing, and let me see how those will apply. And then once I'm done, click save, generates a profile. Later, we'll want it to like auto-apply, monitor what games we're playing to make sure that we apply the right profiles for the right games, etc. But for now, we'll just generate the profile. And that's the goal. A little quick and dirty GUI. So we have made a GUI framework in the past. We have written it ourselves, and we will be using that and using this as an excuse to improve things there that are broken. We call this thing stud. So I think we do git module add, well, the stud is the Spheriphoria standard library. So if I do this, I say, hey, let me pull the standard library here. And then I think I have to adjust this to say, actually, could you be a relative path, please? In here, we should be able to, oh, everyone's saying Proton by default uses XWayland, but it doesn't support host, window, decorations, and other stuff. Yeah, and I think that even if you're using XWayland, I think that the gamma adjustment stuff might not still work. I think. I should double check that, but this is more fun anyways. Okay, so in our stud, we have maybe some environment stuff that we need to pull in. So we have like our GUI framework relies on GLFW and OpenGL. So we need to kind of say, let's pull those things in. So he's got libgl in here. He's got, actually, let's just pull all of this stuff. I don't think all of this is necessary. We need Python 3 is nice. GLFW is needed. LibGL is needed. We probably don't need Clang. Wayland probably is needed. This stuff isn't. Okay, we'll do this. And then do we set like any environment variables? Yeah, so we need to allow our program to find Wayland at runtime. And let's get into the right environment now. Let's do it. Hold on. And in our standard library, we should have a GUI framework demo that we can build and test. So if I do this, and I do this, here's our little GUI framework. A window pops up. Wonderful. So let's start by, I guess, copy-pasting this demo over to our project. And move demo to GUI, and then look at this thing. So we probably need a build script here. Finally, so here we go like this. Stud is import stud. We say, hey, we want to build a project, please. And in this project, we're going to have a dependency on stud, please. And this dependency, stud, this dependency will have a module in it. So we can say, hey, could you pull out the stud module from this thing? And then could you build an executable and use this module in here? So we're going to say like GUI is b add executable. I think that this needs like a root module. And in here, we will call this GUI. Our name is GUI. I think we need to find a target here and an optimize mode. So that means we need target here is standard target options. Optimize is standard optimize option. Boom. Here we wanted to say like add import of stud to stud. Boom. And then we want to install this in the output for the build. Like this. And then we fix complaints. I think name goes here. Root source file is needed. So this is GUI zig. Boom. And he's going to get mad because there's no dependency. We need a build.zig.zon. So this guy is the definition of our project. So this is, maybe we'll call this like gamer ICC or something. And we'll just kind of like start seeing what he complains about. So fingerprint is necessary. Okay, sir? Sir, yes, sir. We will put this number where you told me to, sir. Version is going to be 0.0.1. And then paths is going to say, I'll just leave this empty for now because I know I don't care. Oh, fine. GUI zig. Fine. And ICC zig. I think it needs both of these. What's he pissed about? Am I stupid? Oh, I single quoted, not double quoted. My bad. My bad. Then we need dependencies in here. So here we're like, we have one of stud, and this comes from somewhere. How does this work again? Let's see. He'll complain at us. Path is stud. We're so fucking back, baby. Okay. Now this demo that we copy pasted is using kind of internal standard library names. So we just need to quickly clean these up. So let me pull in this guy. This is stud alec, I think. This is stud render. This is stud window. And this is probably stud UI or something, maybe GUI. I don't remember. Oh, we need to enable rendering on this thing. So true. We have with GL and with GLW. Because sometimes we want this without all of the OpenGL stuff. So we say, sir, I have some requirements of you. And we're chilling. And if we go to zig out bin, GUI, we've got our little demo app working. Cool. Cool, cool, cool. So in this GUI, we want to present an image. Right? So we have a few sample images. Samples. Right? We have a couple of sample images that we want to use for applying stuff. So let's try to load one of these and see what happens. In our GUI, I think we have like this like thumbnail. We called it thumbnail widget, but this is really just like show any OpenGL texture widget. I believe. So can we just try to use one of those? I guess step one is that we need to load an image, right? So I guess in our GUI zig, maybe for now, we will say args is stood process args. And hello, var args. And here we discard the process name. Then we are going to say like sample dir. Sample dir path is args next, or else return error, no samples. And in here, I think we will just load the first one. So can we do something like load samples. And I think that this returns what? An array of textures? Maybe. Stud render texture or something. Maybe we'll say load sample singular. And maybe we won't use a sample dir, we'll use sample path for now. We'll only load one. Later we'll load many, but for now we'll load one. And in here, we will probably need like some sort of image loader. I always go to STB image here for this because it's simple. STB image. Let's get that shit. And then I usually do a little STB image.c as well. And this guy says include STB image.h and defines the implementation. Like this. And then in our build zig, we say, hey, add C source file. File is stb image.c, easy peasy. And then we probably also have to do like add include path of here, this guy right here. Right here where stb image is located. Boom. Svimage when cap? Yeah, I know. We did write a PNG loader at some point, but we never finished it, and I've just never gone back. But you're right. It should be in the standard library. We should have our own image loaders in the standard library. We should. Okay, so now we should be able to go to GUI here and maybe say stbi is import stb c import. I think it's like C include stb image. There we go. Nice. And when we look, there's a bunch of stuff in here that we don't need, by the way. But it's okay. We'll come back. We'll delete that stuff later. So image is stb image load. From here, we'll say this has to be a null terminated string. That'll just make things easier because then we can just do like this. And we are loading this. We have x is a c int equals 0, y as well. I guess this is width and height. Width, height. What else does this guy want? What else does he want? He wants channels in file, desired channels. So here, I think we use null, and we want this thing to be RGBA, probably. I think that's the way it works with our stuff, because then we should be able to go like defer stbi free of image. We should be able to check here if this is null, we freak the fuck out. Load image, which means that this guy can fail, easy peasy. And then we say make me a texture from this thing, which we should be able to do easily. Texture, make texture from RGBA, which gets attached to some memory pool and gets some data with the width of width, which we could probably incast here relatively safely. Don't you need to define the implementation? The implementation is in here. So we pull in this object file instead, because in Zig, the C translation is like pretty damn good, but it's not perfect. So when you try to do something like use C, like include with the implementation, like shit starts to fall over. All right, so what is this memory pool? Stud, render, GLAlloc probably? Yeah, nice. And so we need to say we have this guy, and we want to load the texture. So this is load sample from with allocators, probably root GL is fine. This will just live for the lifetime of the app. And we put this in from sample path. Okay. Let's just make sure that this compiles right now. Error unit is discarded. So true right now. He's mad because expected type conjugate found C pointer. Right. So this thing that we have is a pointer. So we know this is image pointer. We have image slice is image pointer from 0 to 4 times width times height, right? Because we asked for 4 bytes per pixel. Found C int. So these we want like these are going to be called width e and height e for integer. Width e and height e. And then we will do oopsies. Const width u is a u32 of int cast width I, and we'll do the same with height. And then we use u suffixes here, and everyone is happy. And this doesn't have to be intcast anymore. Boom. All right, error union is ignored. So true right now. We do need to return the thing we're making. Okay. Then this guy compiles. Does he run? No samples. So true. Let's do 31. Okay, so he loads. Okay, and now we need to like display this thing. So we in our demo, what's going on here? We set up some OpenGL state, we make some GUI state, and we make a widget factory here. This histogram stuff is going to go away because we're not using histogram. But it looks like all we got to do is say layout push widget, try widget factory, make thumbnail, I assume lives in here, hype, and he wants a retriever. What does this retriever want? Probably just the texture, right? Texture, get texture. Why is this like this? Oh, sure, because we might have like some like complex way to get it. Sure. Text retriever is a struct who has the texture. And we have like a pub function, get texture. Return self texture. Easy. This allows us to kind of like support pointers, support other stuff. Like this is just simple. They are, I shouldn't say simple, but like nice and generic. Okay. So does this like show the image? It might. No field get size. Ah, I see. Because the texture does not have size information associated with him. It makes sense. What does he want him to return? Image dim, so probably get size. How does he use this? Width and height. He needs a struct that do we have like maybe stud GUI pixel size? Probably. Width and height? Yeah, that should work. That should work. So really what we actually want is this guy to return a text retriever. Or maybe we even call this like an image, to be honest. So this guy returns an image now. And his image is texture. Width is widthu. And height is heightu. And then here, we can use U32s here, probably. Maybe U31s even. I think that's what the pixel size wants for some reason. I'm not going to explain why, but that is what he wants. Width is self-width, and height is self-height. And now this should be fine. So we should just be able to return this like this now. Pointless discard of local constant, so true. Also, this is an image now, not a text. Using U31 so casting all the U32 for OpenGL stuff is easier. Yeah, true. I just didn't want to have to like explain that because people always ask. And I was like, just don't worry about it. Don't worry about it. Okay, so we have a fucking null fucking garbage ugly image. So let's just double check a few things. So it does in fact give up if we give him a bad image. It could be that the RGBA format of this thing is not what we expect. Maybe what we do as a stopgap here is we check that if we write this thing back out, we see what we expect. So for 0 to widthu, for 0 to heightu, can we just write out this thing as a ppm or something? Stud fs current work directory open create file sample ppm. And what does you do here? I think it's like can we have a writer? And I'm just gonna do a cardinal sin here and do unbuffered writing. And you can't stop me. And then we can go, I think we start by saying I think it's like P6. I need to look it up. ppm format. Then it is width height bits per pixel. So this is gonna be width height 255 or max value, I guess. So here we have width to heightu, and then we just dump out the binary data RGB style. So C is gonna be the image at Y. Pixel offset is gonna be like Y times widthu plus X. And then this is going to be pixel offset times 4 from 0 to 4. And then we just write out the RGB values. So it's like ppm writer interface write byte of probably C0, 1, and 2. I don't know if it's I don't know like the byte order. It might be not like this. It might be a little off. Whoa. Okay. Holy shit, that took a long time. That's funny. Sample ppm. Okay. So that seems to be a reasonable picture, right? If XCG open samples 31. Yeah, these are the same picture. So the question becomes, why does loading the texture not work? So we're confident that the image we loaded is good. We are less confident. Oh, because we're loading the sample before OpenGL is initialized. That's probably it. Yep, there we go. It's upside down. So we need to ask him to not do that, which I think you can do like, there's some sort of like flip on load true. 1 maybe? There we go. Look at that bad boy. Look at that bad boy. Path is a dir, an image path. It's an image path, but it should be a dir. We'll get there. We will get there. So now we are going to say, give me the dir. This is a sample, and we'll say, we should probably load this after our OpenGL initialization as well. We should probably just do this down here. So can we do like image dir is stud fs current work directory open dir now of the sample path. And then we're gonna like iterate these. So we're gonna go like I think we need to say like I want to be able to iterate this thing like this. And then we say image. Oh, I guess we have like dir iterator is image dir iterate. Yep. While probably try dir iterator next. Entry here. Can we do a quick little check if entry name? I guess we'll literally just take everything. If you put other things than these images in here, fuck you. Later we need like a GUI probably to like open files manually, but for now we do this. And we just do this. Easy peasy. I guess this should be from entry path name, which means that we need to do std fs like path join probably, which we'll use the scratch allocator for this, with sample path and entry name or something. Image path is this, probably. And we say, checkpoint is allocator is scratch checkpoint, and then we defer allocator is scratch restore the checkpoint. We just leak by design and then deal with that shit later. All right, that seems kind of reasonable. These thing, we need to do a little, oopsies, little join Z for null termination on that bad boy. Not dir, huh? Because we're running this with not the directory now. Okay. So now we do, in fact, have 3 images loaded. However, they look fucking crazy style. So we want to put all of these images in a scroll view, which I think we just don't have right now. So can we just do like try widget factory make scroll view of layout as widget, and then use the scroll as the root of this guy. And I think the scroll just is a widget. Closer, they still seem to be using the available width. They seem to be confused. We maybe have just never done this before, and the widget might be fucking broken. So what is going on here? What is going on here? We have image, we have thumbnail zig. How do these guys determine their size? They say, hey, this is the size of the image, and this is the size that is available to me. And I'm going to fill the available width, the larger of the available width or height. Oh, sure. So I guess we're supposed to just like, we're supposed to clamp these guys. This is like a thing that we do often in this GUI framework, I think, is we just say like, let's just like make a box. Make a box, stick the thing in the box, and then it will try to expand, but like, I don't give a shit. So we'll just say, height, we'll say width is, I don't know. We'll limit the width to, it would be nice to have some sort of dynamic box that like clamped height or something, but like kept width. But for now, we will just do 800. And we'll just see if that kind of like makes it at least kind of work. Oh, we do have fill style. Wait, look at this. Fill width. Oh, so we just clamp the height. Yeah, say no larger than 600 tall. Wait, we're fucking geniuses. We're fucking geniuses. Oh yeah, look at that. Look at that. Oh baby, that feels good. Talking 2x2 grid might look better. Whatever. I mean, yeah, we could probably do something where it like dynamically like picks like the best width or something, right? So like if the image width gets above some level, then we would allow like flexbox style, but I think our layouts aren't that advanced yet, so we just won't do that. Okay, so I think what I want to do now is I kind of want like a sidebar here, so that like I can kind of scroll on the right side of this thing and then apply settings on the left. What is this comp is? Kwin. Kwin is what's doing like the wiggly window shit. So how do we do that? We do some sort of horizontal layout, I think. Also, let's get rid of these fucking, like, graph shit. We'll come back to that if we need it. And the text box. Fuck this text box. Fuck all that shit. And what are we going to do? We are going to say, so this layout that we're using here, this is the, like, image layout. Okay? And then we have a top level layout. Okay, and then I think that we can, like, set the layout direction. So we go left to right on this bad boy. And then we can do, top level layout, push widget, sidebar. And we also push in the image layout, like this. And then here we use top level layout instead. And this is actually the scroll, this is scroll, like image scroll, we'll call this. Okay, so then we just need the sidebar. So this is going to be a probably like boxed thing, right? So we're gonna be like, make me a box. And this box is going to have some sort of like sidebar layout. And we are going to say limit the width to 300 pixels and the height, we will fill height here for the sidebar. I think that makes sense. And then we just need our sidebar layout. So for now, we will just allow this to be empty, I think. Yeah, we'll just do this. So here we should see, oh, there's some like, stuff left over from the demo that I don't give a fuck about. Don't worry, it's for browser soon. God damn it, dude. That one's like, if we stream for like 5 years, it'll happen at some point. But not right now. But that's definitely like on the list of things that we could do at some point. Okay. So this sidebar, maybe he needs a little bit of content in him. Can we do something like a push widget, try sidebar layout, widget factory, make text box, sidebar text. You know what I mean? Like, let's just kind of like see what's in here. And oh, not text box. Make label. Sorry. I just want to see if this is working the way I expect. Okay, here we go. So we have our sidebar. Now, he is not filling the space like I was expecting. So this box is not the way. We've done sidebars before in like our image editor. How is this guy constructed? UI zig, maybe? Sidebar zig? What did we do to make this thing? Where does this get constructed? Make sidebar, maybe? Yeah, nice. So this guy, he makes like a rectangle in here with a background, and then he puts the He asks to fill height at this height. So it's probably this rectangle is forcing this thing to grow, and this is because we wanted a background on the sidebar. Yeah, that seems reasonable. That seems reasonable. I can see why we would have done it that way. So what did we do? It was like sidebar background, widget factory make rect, and then this got put in like a stack, probably. So we like stack two widgets on top of each other. And this guy has two elements. We say, hey, could we push a widget? We probably put the sidebar layout on top of the background. And here, I think we kind of just use defaults and see if it yells at us. We'll just see where this goes. I really don't know what's happening. Like, at all. Okay, and then we use the stack here. Oopsies. Okay, that's better, but now I'm missing the text. Maybe it was the other way. Yeah, I see. Okay, here we go. Nice! Nice! Okay, so now all we gotta do is add some sliders here. All we gotta do is add some fucking sliders. I guess at some point we started like, you know, general GUI, like GUI layout stuff, which we are not quite done yet. Let's add the slider for gamma, which I guess is kind of like the next section, right? We'll kind of say that. Apply gamma and preview. So we, in our sidebar, want a slider, probably a label. So I think sometimes what we do here is we use like a grid for this stuff. Yeah, because we might want, or like make... I seem to remember having like a specialized grid for like key value stuff. Label, button, selectable list, color picker, drag, float, drag, layout, property list. So here we limit the size of the property list. So let's just say, you know, it won't have more than 10 things in it. And then how does this work? We like push probably gamma, and then we push in the like dragger. So this is gonna be a drag float, maybe. And he needs a retriever, which I believe can just be a pointer to the gamma. I believe that's legal here. When this thing changes, we need to be able to do like make update gamma. So he's gonna like provide us a request to do something, and so we need to tell him to do that, and we'll say we drag at like probably like 1/100th of a gamma per pixel or something. So we kind of start this shit at 1, probably. And we need to say, hey, GUI action, where the fuck you are. You have update gamma as one of the things that the GUI might request us to do. And it's probably like make update gamma takes in a new value. I don't know if it's a new value or a delta, not sure, but we'll see. But that should be sufficient to make this compile and show. No, because we haven't compiled this in a while, and our grid class is using out-of-date stuff. That's kind of fun. Runtime segmented list, probably. And, like, what is this supposed to be? Runtime segmented list. And then this guy needs expand. I think it's like alloc expansion. Yeah. API changed at some point in the past, and I just kind of forgot. Okay, what's this guy mad about? Unable to resolve comp time value. What? Oh, because the function pointer, this needs to have an ampersand in front of it, or else he thinks it needs to be comp time. Yep, there. Okay, so now we have this gamma slider that does nothing, right? And then also that looks like shit. So can we put the whole sidebar layout in a frame? There's a way to do that. It's okay, we have the box as the sidebar. The box is around the stack is around the layout. The layout wants the frame. I believe it's like this. Try widget factory make frame around the layout. Like this or something. Whoa, 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 whoa. Maybe like this. There we go. So now he's not so pushed up against the fucking edge of the world. And now we just have to make it so that when I slide on that thing, it does something, right? So response action. If there is something that you've asked of us, switch on that action. And that action should only have the ability right now to be update gamma. New gamma. And here we just say gamma is equal to new gamma for now, but this is where we will update the texture as well. Okay, yep, we're seeing this gamma slider change, which is great. We could also do clamping here if we wanted, but for now we will let it go crazy. I think probably a window that's like a little bigger would be nice. Also, can we change this to say gamer ICC while we're here? And let's do 1024 768 as our default. I want it to be fatter, 1600. Too wide. 1280 by 768 maybe. That looks pretty good. That feels good for now. Feels good enough for now. Now, when we do this, we actually have to update our fucking texture. So how do we do that? We probably need to like double buffer this or something, right? So we have like the texture loaded, that is the source image, and then we apply a gamma curve in the shader and output that to another texture that gets displayed later. So we probably want to do something like keep track of all of the images that we've loaded. So can we say like a modifiable image, right? And we'll say this is the like source, and this is the modified. Something like this. Okay. Then we, for each sample, this is going to be the modified, or the source is this thing. And then the modified is just going to be invalid, or I think there's an invalid texture handle thing that we have in there. Yeah. And we need to then like stash these somewhere, right? So we're going to have like textures is going to be a like stood array list, I guess, of modifiable image. And we will put this in like the textures buff or whatever. I'll just say like here is 3 modifiable images. Boom. And as we iterate this directory, when we load these things, we say textures, append image or whatever. We call maybe images is better, but whatever. Does thumbnail allow you to override the shader user to draw? For this use case, it would mean less textures to keep track of and less copying. Yeah, I'm on your side. I'm on your side. I would, well, right, so we have 2 options here. One is to like make a widget that wraps in our like a custom shader, which I think is fine in this case, to be honest. And then the other is to output to a texture, render to that texture, and then tell this guy to update. The reason I was leaning this way was it means that we only have to do the extra rendering one time. But I guess you're right that every frame we're still rendering the textures. So like the extra shader pass of like applying gamma as you sample is like basically nothing. Yeah, that is better. Let's make a custom widget. I agree. Modified image widget. So he has a source. He has a width for image width in here and an image height in here. And then we are gonna want some sort of like program, right? And this is probably going to be a XY transform program, XY UV transform program. Probably this. He needs his UV coordinates as well. And we have like an image renderer thing in here, which is close to what we want, but not exactly. So I guess let's start by just rendering, like using the existing image renderer, and then we'll kind of figure it out from there. This guy needs to be able to be viewed as a widget. So this is going to take in self, and he's going to return a like GUI widget that is backed by these GUI actions. And his context is going to be like myself, and he's going to have some sort of like render, like actions that he has to provide. Name is modified image widget, and vtable is going to be whatever this vtable wants from us, which is this stuff. So he needs a render function for sure, and he has a get size function for sure as well. And an update function is going to be used to kind of like be similar to what the like eat up the surrounding space if applicable, if possible. So these three functions need to be implemented here, and the rest of these I don't give a fuck. So this is render. This is get size. And this is update. Okay. Need to do some like fix-ups on namespaces here, like this. And our render function, I guess we start by copying the thumbnail render function, who calls image renderer with a transform. Easy. So he says, give me my widget bounds, and let me get the texture, which we don't have a retriever anymore. This is just embedded in us. Like this. And then we have our image renderer like this, which is probably comes in as a pointer. Probably. There's a program here. Easy. Get size. He returns self size, which is probably stashed in update related to this math, and we'll just copy paste this. This should be fix me likely some duplication here, but whatever. We have self image width here, self image height here. This is self image height, as is this, and then this is self image width. This is just some like aspect ratio preservation shit, I think. All right, so now we should be able to make these modified image widgets instead. So instead of returning all these textures and stuff, this load sample returns a modified image widget. Okay. And they need the program, so program. Uh uh like this. Okay. Now when we load this sample, we need this thing, which probably we have in like GUI state somewhere. Yeah. Okay. Get size, not marked pub. Wait, what? Oh, oops. We're image as widget should just go like this now. Cool. And this thing now needs to actually be like a stable pointer. So this is going to return like this. And this is actually going to take in a heap allocator and a GL allocator. So this is kind of like this. And ret is going to be a create of modified image widget like this. We set the value of this here and then return it like this. Easy peasy. And now we leak this shit all over the place, but I don't give a fuck. Like this. No field size. We do need to make a size here. And then when we load this thing, we need to set the size to something. Can we just default initialize it and let it figure it out later? Yep, missing set input state. So we need to manually flag all the rest of these as null, I guess. Set input state is null. Set focused is null. Reset is null. All right. Cool. We're still back and everything is still working about the way it was before, which means that this is probably working. Now let's change this program. So we are going to have kind of like our own program here. And what does this do? He calls render on this program. Does he not need like data associated with him? Render source here. Oh, so we have self render source here, which he probably constructs as like a square. Yeah, he has make full screen plane in here. Yep. Okay. Understood. So we want to do something where we override the program in here. So it's been a while. It's been a while since we made an OpenGL program, so let's figure this out. This is a stud render XY UVT program with our uniforms. So uniforms. And our uniforms are going to be gamma, right? As well as the texture. Which I think we can use as a texture. This might be wrong. Can we, hold on. What did this guy do? Image sample uniforms, he had this stuff, so we'll just copy paste. So he has the input image, transform. He also has a depth in here, sure. For like layering, I guess. And can we? Yeah, I guess it's fine. When we render this thing, I guess we need like the render source for an OpenGL buffer to draw, or an OpenGL like geometry to draw on top of, which we're just gonna do as a full screen buffer. And then it should be we should be able to just be like gamma self gamma. What else does this guy want? He wants the uniform, so it's these guys. Input image is self source. Transform is transform inner. And depth is unset. And is that literally it? We do need to assign this program at some point. So now this program is actually going to be maybe kind of like this, maybe like this. And what we actually usually do here is we have like shared data where we stash all of the stuff that's common for all of these widgets. So like in here, it'll be these guys, right? And then we'll have shared like this. And then this shared gets probably like initialized somehow. I don't know. This guy probably is going to do some OpenGL allocations, surely. So he is going to be like one of these guys. Initialize with the GL alloc and our fragment shader. Modified image frag or something. Yep. Okay. So this is the program. Render source is try. I think we saw in here there was like render XY make full screen plane. Perfect. Perfect. And then we should be able to just like return prog is prog, render source is render source, and gamma is 0. Right? Then we pass in the shared data here. And this guy gets shared is shared like this. Beautiful. Beautiful. And then this load sample needs this shared data. So var shared is modified image widget shared initialized with the allocator's GL allocator. Boom. This can live for the lifetime of the app. Easy. Then this gets passed in here. And all we need to do now is write a fragment shader that doesn't fucking suck. So can we just copy the image renderer one for now? Image sampler frag RGBA. And then we do a little quick little uniform gamma of float gamma. Okay. This thing can fail, which means that this guy can fail, which we already had written there. Render source is mad because we got a buffer. So he does it like this, and we will copy paste whatever he's doing. Okay. Boom, boom. XYUVT program like this. Okay, cool. Does that work? Closer? No field name program. So it's self-shared program now. All right. Closer. Self-source is shared source. Render source. No. Render source here and then source here. Okay. We're so back, baby. We're so fucking back. And now all we have to do is attach the gamma, get rid of this local gamma variable, and this is now attached to the shared gamma. And this will automatically get applied everywhere. And now we just need to make it so that that gamma is applied in this shader. So here we can just do pow gamma. Sure, vec4. Okay. Oh, baby, let's fucking go. Wait, that actually fucking works. And this is not gamma. I guess this is like gamma adjustment. Gamma correction or something is like the better label for this. Gamma correction, I guess. Let's fucking go, baby. And so now we can like look at like some of these pictures and go like, so it looked like this. I think it should look like this. And then we can kind of look at these and be like, this one still looks okay, right? This one was gamma 1.0. We go gamma 1.79. It still looks okay. Sick. Sick. Okay. So now all we have to do is take this gamma curve or this gamma that we've selected and add a button to write out the ICC file. So in this sidebar, I think that we are going to have a little key value thing where we kind of have like a make text box. Which we had as an example in the demo. So this just takes a slice, and then he has like a text edit request that comes in with this thing. So for now, I'm just going to hard code this to out ICC, but eventually we will. Actually, yeah, we'll just do this for now. For now, we will. I want this to be like a modifiable thing later, but we take things in pieces. So make button, we'll say save or something. And then on save, we need like a save action. You know what I mean? You know what I mean? We need him to say, we need to handle all possibilities, so true. Std debug print, save time. And here, oh, this is some bullshit. I forgot. What is the fix here? So when I type GUI action.save, this actually doesn't have the type of GUI action. This has the type of GUI action backing enum. Do I have to do this? Yeah, gross. If any like Zig heads know how to avoid this, make button takes in like an any type, and this like propagates all the way down to somewhere where it gets saved. And I want this save type to be like a GUI action, and the GUI action has like a save element here. When I type GUI action.save, it's like not the right type because it's like the backing enum. So I don't know how to deal with that. But it's annoying. I don't want to have to type this ever. Okay, so now all I have to do is when we save this thing, we generate an ICC profile, right? So we should be able to go like, import ICC, which we wrote the other day. And in here, we should be able to write something. And this thing is going to try to sample some curve. So let's call this like sRGB in gamma sampler or something. That's what this is supposed to be. So we're doing the inverse of the sRGB. We're doing an sRGB output curve with an inverted gamma applied on top. That's kind of what this is supposed to be. Then we put this in a file. So we say f is current working directory open file of out ICC. I guess it's create file. We're gonna say out buff or writer buff here is some stuff, and we say give me a writer on this file backed with this writer buff, and then we use that writer here, and then we flush that thing after. Does this thing have a flush at the end? Because I don't think he should, to be honest. I think that's kind of like my job externally to flush. Okay, and his params are all this thing. So what do we want? We want copyright, none, easy. We want description is gamer ICC output or something. We have the samplers here, so we're gonna be like, make me one of these guys. So this is going to be the same for all of red, blue, and green. We need our color transform, which we are not correct over here. But we'll copy paste them for now. These are like incorrect color transform. I know it's incorrect. So all of our things will kind of like tint a little bit yellow for now, but we'll handle that later. And then I think that this gamma sampler is literally the same one that we wrote over here. So this guy is going to apply a gamma curve to an inverse gamma curve to this thing, which is just x to 1 over gamma, and then he's going to export an sRGB curve on top of that. But I think that should be fine. sRGB in gamma sampler. Okay, so I think if we build this and then we kind of pick a gamma that looks about right, and we hit save. Did we flush? Try writer flush. I think we should get something that approximately looks like this if we load this with the MPV. That's kind of the dream. So can I do something like MPV, ICC profile, and can I open samples here? Oh, samples, 031 PNG? Oh, I'm in the wrong folder, that's why. Oops. Not quite, because the transform, we know that the transform's wrong. So all we're really looking for is that it's brighter or darker than it's supposed to be. So if we look at this with maybe 091 with no profile, it's relatively dark. It looks like this. Then we load it with our profile. Okay, that's interesting. So this is the amount of change that we saw. This is the amount of change that we're getting. If I like really crank this and then try this again. Yeah, I mean, we eventually get there, right? So we have something that's like kind of working in the right direction. Um, but I believe since we kind of left all of the how's this? We left all the color transfer matrix stuff wrong. I think that it's hard for us to diagnose exactly what we're doing incorrectly here. The important thing here is that we have a GUI that does what I want, right? So the next steps here are to make it so that the math lines up. Does the ICC expect the actual gamma value? Because your shader has relative value, I think. The ICC expects like the ICC file expects a response curve of how the monitor of the measured values that the monitor produced at certain light levels. That's what it expects, which is very different than the gamma curve or the inverse gamma curve. So we're kind of giving him like an sRGB curve that then gets adjusted with our gamma curve as well. Like it kind of gets like kind of squished down by the amount, which might be like mathematically wrong. I'm gonna have to think about this, but I am happy with this. That's a problem for tomorrow, right? The goal for today was specifically to get this GUI working, and I think that this is working pretty well. It's not very useful if this GUI's output does not match the profile output, but we'll deal with that later. Cool. I think this is a success. Thanks for watching. If you like what you saw, we stream most days. We aim for 12:30 to 4 Pacific time. It is 3:20 now. Are you going to make it auto apply K1? Yes, eventually. Yes, that'll be an option. Yeah, we're working on this right now. We're going to get back on the Wayland compositor soon, assuming we don't get distracted by something else. There's a Patreon and a YouTube members and Twitch. If you sub on any of those, you get access to the VODs of everything. So this is posted on YouTube, but there was a section from earlier in the stream today where we were working on kind of cleaning up the ICC profile stuff, and that kind of goes in like this like happy hour segment, we call it. So I think if you want that, feel free to support. If not, no pressure. Thanks for watching. YouTube, peace out. Twitch, let's find someone to raid.